Welcome to Spring LIB.
So here we can say that the change in mass, dm, is going to be equal to the mass sub s divided by d times dx. So v is going to equal x, v naught divided by d, and we know that the kinetic energy final will equal the kinetic energy m plus the kinetic energy s. And this is equal, and we can say that this final kinetic energy equals half of mv initial squared plus 1/2 v squared times dm. So essentially we can say that the final kinetic energy is going to be equal to 1/2 m times v initial squared plus 1/2 times the integral from 0 to d of x v initial over d times dm. So in this case it's m sub s over d, and then again times dx. We can then say that the final kinetic energy, rather simplify, so the final kinetic energy is going to be equal to 1/2 times mv initial squared plus v initial squared m sub s divided by 2d cubed, and then we'll finally integrate from 0 to d of x squared dx. And so we find that the kinetic energy final will equal 1/2 mv initial squared plus v initial squared m sub s divided by 2d cubed, and then times d cubed over 3. And this is giving us v initial squared over 2 times m plus m sub s over 3. And at this point, we can label this for a generic speed. So we can just say that the kinetic energy final in terms of v, any generic speed, is going to be v squared over 2 times m plus m sub s over 3. This is our final answer. That is the end of the solution. Thank you for watching.